All right, I think we'll kick this thing off. We'll go about 2 minutes early, so that maybe we can get you guys out of here a few minutes early, too. If you're going to be so jazzed about this stuff, though, you're not going to want to leave. Okay? So we're here today to talk a little bit about how do we reuse the 2D geometry that we have and get into the 3D world. And, you know, we've been hearing a lot about that in product design. We hear tons of it. And we know it's fairly obvious what the benefits are there. And there's a lot of benefit also going to the 3D environment inside of the plant world. Obviously, you know, if you guys have ever done an installation, ever had something go wrong where something didn't fit, it's usually because it was probably done in 2D and somebody missed something. So we give you a lot of tools with Factory Design Suite that make it really easy to work with 3D data. So I'll give you a little bit of my background, just a 2-minute overview. My name's Mike Joliker. I've been with Autodesk for about 15 years. Worked in plant design, plant layout for Mercury Marine for about 7 years in another life. And again, I would have killed for tools like this. Just absolutely amazing. So believe me, I know the pain of getting a call at 3 o'clock in the morning and having somebody tell me something doesn't fit. You know, the most expensive sound in the world is the sound of a acetylene torch popping in a plant, you know, with a millwright standing there with it. So we'll go ahead and get started here. And what we're hoping to do today is to talk about what we would do and deal with our 2D data. So basically, you have to create a 3D layout, and we're starting to see more and more of that now. I work out of Detroit, so what we're seeing is in the big three especially, and a lot of the larger manufacturers, it's not an option anymore to deliver 2D data. They now want 3D data. They want all of the machines in 3D data. They want all the layouts in 3D. There's a lot of reasons for this. But they have discovered, they went through the pains early on, and they've discovered now that they've built a process around it that they can save a lot of money and they save a lot of headaches by doing things in 3D. It does a lot of validation for them. So where we are in our process right now is, you know, thanks for letting me know. Okay, yeah, your class is now. Okay, good. Okay, so you know what equipment you need. So basically, you've got a good idea what your layout is. So maybe you've got blocks, 2D blocks, things like that. Maybe you've gone out on the web and found some 2D drawings. You know what they are. So one of the things that we're looking at here, too, is not only do we want to use these things once, but we're probably going to want to use them again. We're going to want to be able to share these with our team. We're going to make sure that other people are able to use and leverage these things in 3D and also be able to generate the 2D drawings with them. So you basically have the 2D drawings of this equipment. So the question is, how do I create the 3D assets of them? And when I say assets, I mean just basically pieces of equipment or machines that are going to be going inside of your layout. How can I do them quickly? How can I do them accurately, painlessly, and have them be reusable? So those are the things we're looking for. Hopefully at the end of this class, you'll have a pretty good idea on how to reuse 2D geometry to create 3D geometry. You'll be able to add intelligence to that 3D geometry to make it really good functioning 3D factory assets. You'll be able to employ some strategies to make them good factory assets. There is such a thing as a bad one. Just like anything else, like any model, if they're not created properly, it can be a headache. So the other idea is to use these 3D assets with Factory Design Suite. So be able to drop them into place and you'll understand how they work and what they do. And I just want to do a little bit of level setting in here quickly. This is not a wizard or a silver bullet, okay? There's no magic here. We don't have a magic wand that just magically turns stuff from 2D to 3D. Doesn't exist. Been looking for one forever. I figure if I could figure that one or perpetual motion out, I think I'd have it made, okay? The reality is there isn't a real good way or an automatic way. But there are a lot of good things that we can do and some ways that we can work with it. So let's talk a little bit about why we would do this. What's the reason? So we have 2D drawings. Why not reuse them? Absolutely. You should. Right? You put a lot of engineering and a lot of time into these 2D drawings, or somebody has. So it just makes sense to go ahead and reuse them. But there's a couple of things we want to think about when we're making these things. This piece of equipment that we're making, is this thing a one-off? So basically, is it a large piece of equipment that's just going in our plant and we're only going to use it in that place just that one time? Or is it going to be a many-use asset? Maybe it's one of that kind, but we're going to be putting it in all kinds of different places. Okay? The other thing we want to know is, does this thing change in size or configuration? Does it get bigger or smaller? Does it come in different sizes? Like conveyors, they come in 10, 12, 14, 16 feet and come in different widths. Or does it connect to others like itself, or do things attach to it? Again, like conveyors. So if I put down one conveyor, I want another one to automatically connect to it, and so on. Okay? So these are considerations or thoughts, a thought process that we want to go through. Just like when you did your drawings in AutoCAD originally, there was a thought process that you did. It was a little bit different, but basically what you did there is you were considering what layer I should put things on, right? I have to follow my layer standards. I have to make sure that my dimension variables are set and so on. All of those things. So basically, it's not like the worries went away. You just have different ones now. Okay? But they're really not a big deal, and they're easy to work with once you understand where you're going with it. So some one-off asset examples. A lot of times, at least in my dealings, I found that a large customer will be working with a machine supplier that's making a large custom piece of equipment. And they're able to supply them with a 3D model. And that 3D model could come from SolidWorks, it could come from Inventor, it could come from Pro-E, it could come from Unigraphics, it could come from just about anywhere, really, right? So they don't really change in size or configuration. It's just their design goes in, it sits in place, and that's it. Okay, so it's just a machine. The thing we're looking for and what's important to us working in the factory environment is space claim. That's what's important. Everything inside of the machine doesn't mean a hill of beans to us. Okay, doesn't matter. And it's really interesting. How many of you, okay, some of you guys are working in 3D already. How many of you guys have gone to people and asked for 3D models? What was your success on some of that? Yeah. And you know what's funny? Some of it is it's not a matter of that they can't give them to you. They're afraid to, right? Because they feel there's intellectual property. They're giving something to you like you're going to reverse engineer this thing, right? And make, I'm going to go into business making machine tools like this. Not likely, okay? But, it's a reasonable thing. But the thing that you got to tell them is, I'm not interested in anything inside of that, okay? In fact, if we're going to use these, if we're going to reuse them as 3D assets, you should request from them if they can gut the inside of them for you, right? And what better place to shrink wrap or gut something than the original tool that was used to create it, right? If it was made in Pro-E, use Pro-E to go ahead. Use their shrink wrap tools. Have them get rid of all the guts inside and just give you the outside shell, okay? Now, Inventor does have tools that allow us to be able to do this. But again, the best tools to do that are the native application where they came from. Okay. The other thing to remember about these too, when they change in size or configuration, they could get bigger, smaller, and so on. But the other things that we're looking for in the these are unchangeable assets. Okay, so these can come from anywhere. They're vendor supplied. They could be internally made. They're usually an inventor most of the time. Now, some of the stuff may have come from somewhere else. But if we're going to change it or change the geometry, that occurs inside of Inventor. Okay, so it's a parametric dimension that's causing something to happen, or a configuration. It may or may not connect to other pieces. So in this case, like this drill press, we have a 1 spindle, 2 spindle, 3 spindle, 4 spindle, and so on. And we can just go ahead and change them all day long. Then we have what are called connectables. Connectable assets. These can be, again, vendor supplied or internally made. Another question, how many of you guys have seen Factory Design Suite? Have had it demonstrated to you? Seen it? Okay. We have an online library that's actually cloud-based that we update probably every couple of weeks, and we add more and more data to it. All of the assets that are up there are built, or the ones that are appropriate to, are built automatically with the connectors in them, so they know how to connect to each other, and they know how to behave with each other. Okay? But when you think of those assets, a good way to think of them is starter assets, okay, or seeds. So when you pull them down, you could use them and drop them into your layout right away, but usually the best way to do it is to bring them, copy them, make them your own, You're going to have to anyway, right? Because you're going to have to add your own part numbers and all those other types of things. So at any rate, that's what these do. Well, why are they different? So the one-off may connect to others. Parameters aren't really required. Okay, you don't need anything there. So in reality, they're fairly tolerant too. So it's like I can reuse kind of crummy outside geometry. I can kind of hack it together, okay? You can blast these things out really fast, okay, depending on what it's going to be. The other approach is it changes in size or configuration. These ones require parameters, and they're going to require good sketches to work, okay? Otherwise, you're going to have nothing but headaches with these things. So what am I building up to on this, right? So we've got these AutoCAD drawings. Remember, we'll come back to that now. We've got AutoCAD drawings. And we're looking at what do we do with those? How do we leverage them? How do we do anything with them? There's a thing inside of Inventor. I don't know if you guys have used it. It's called Import DWG. So Import DWG allows us to be able to create a part from a drawing. And basically what ends up happening is that DWG or DXF file becomes a sketch, or the base sketch inside of Inventor. And we can reuse that. This may work probably for the one-offs. It won't work very well, though, when you start getting into these others, which are the changeables. Cut and paste and Twig Overlay are the way we're going to do this. And that's, so if you're to have one takeaway today, that'd be it, okay? So again, let's talk a little bit about this. You can reuse, the import Twig and DXF. Some of the neat things, you can reuse geometry, you can reuse dimensions, which is actually pretty cool. They come in and they become parametric dimensions right away. You can go in and constrain them and you'll have kinds of behavior. It's really neat. Works great if your drawing looks like that. Okay? So, very simple drawings that works good. In reality, drawings usually look like this. Right? They have all kinds of things on them. They've got lines running in here. This little guy right there in the middle, that logo. Ooh, those are bad, right? You don't know where that came from. You don't know where it's been. So they're made up of splines. They're made up of all kinds of ugly things, okay? What's that? Yeah, no, you wish. So other things, there's dimensions, there's text, all kinds of other things that we have to deal with on here too. And when I did this in mine in 2013 on a fairly fast box, it took about 5 minutes to open this sketch and have it be unconstrained for this drawing, okay? This is a drawing that was supplied to me by a customer. Or we take a look at one of these, I've got this drawing, and what ends up happening, where did this come from, right? It looks pretty cool. What's obvious about it? At least what becomes obvious to me? Or either that, or it came from came from another 3D system, and they created a 2D drawing from it, right? These things are ugly, okay? So 7 minutes to open and sketch, and that's unconstrained. That's 7 minutes of my day. I suppose I could go get coffee, but I'm not liking that, right? And the problem that we've got with that is because you've got things like these hoses. They're made up of splines. We've got all kinds of overlapping lines in here because they took that 3D object and squashed it, okay? So we got lines on top of lines. There's all kinds of things going on there. Inventor does do a pretty good job of cleaning that up. But remember, that's just overhead. Those are things that we have to deal with. Another big one is scale. This is one of my favorites. And just to give a little sense of, of frame of reference, I've been using AutoCAD since 2.62. I started using AutoCAD over 20 years ago. Should start a support group. Right? Hi, I'm Mike. I use AutoCAD. But at any rate, one of the things that people would do, that's way back in time, right, before we had things like layouts and we had views, drawing views. If I wanted that in there, I would just scale it, right? We're going to just scale that and we'll make it fit on a sheet. Well, that starts to become a real problem, right? If you're going to go ahead and use this, I'm going to go create a new model and get the whole thing done. And wow, it's 25% too small, right? Because where you started from is it was scaled wrong. So you got to go check things like that. Okay, the other thing is open profiles, and these things are a real bugger. Okay, so you'll have places, for example, where you can't even see it. But the lines and the curves aren't coincident. They don't touch each other. And I don't care how long you work on it or how hard you try, Inventor will not extrude that until you close those. And some of them become really, really hard to find. Okay? And there's probably, obviously, a lot more detail on this thing than we really need. Remember, when we're doing this kind of work inside of a plant layout, we're only interested in the space it occupies, unless we're doing some kind of a really pretty picture like we're trying to sell a project to somebody. Okay? For the most part, though, that's just a lot of extra detail that we don't really need, and it's just going to add a lot of extra weight to your models. So this is your basic result. Garbage in, garbage out. And really, this isn't all that accurate. In reality, it's garbage in, distributed garbage out. Remember, the stuff that you're making here, if you're the guys that are creating assets and you're creating them for all the other people on your team, and now we have the ability to share these assets out on the cloud, right? Cloud-based, you can go grab them. It's very easy to perpetuate a lot of junk really, really fast, okay? So it's only as good as what you put in it. So you got to be kind of careful with this. So I'm going to show you guys a couple of workflows that hopefully, I'm just going to take a look here. I'm kind of rolling right along here. Yeah, yeah, you guys won't mind if I get done early, will you? But, so what we're going to look at here is how do we avoid these things? So if you're going to reuse the sketch geometry, right, be very careful about how you inspect it. Go through it and look. See what these little objects are in here. Those are, if that's a P-spline, that's bad. Replace it with an arc, okay? Don't use splines unless you absolutely have to. Not only do they add a lot of weight, but they're also very difficult to control with parameters, right? I liken it to pushing a rope up a hill. You know, it's just, you know, it's going to go all over the place. You're not going to be able to, you know, get a handle on that thing. It's going to do all kinds of weird things. And again, like I said, that logo, right? Don't model it. What usually ends up happening with things like this is somebody put a lot of personal love and tender care into that thing, right? It was really cool. They wanted to make it look nice. So they spent a lot of time drawing that, but it's made up of a whole bunch of hacked up stuff. Don't use it. The worst thing, and I've run into this, you'll get models, and I'll have models that people will send to me, and they're like, it doesn't perform very well. And I'll go and look, and there's extruded text in it. Don't do that, all right? Stay away from it. Resist it, okay? So the basic thought on this, again, is if we're going to use this workflow, if the drawing is fairly clean and simple, we can use it. If the scale is properly set, and if there are not a lot of entities in the drawing, okay? So again, when you do entity counts on these things, sometimes, like that one drawing there, you do an entity count in it, there's like 3,000 entities in there, right? Who knows what they are? They could be text, they could be anything. But the reality is there's a lot of them. And that means that Inventor has to chew on all of those. When you bring those in, and you bring them in as a drawing like that, Inventor goes and looks at it and tries to solve and parametrically constrain all of the pieces for you, right? So if there's 3,000 points in there, that's going to take a while. You know, it's got to figure that out. So we want to kind of avoid that. It could be used. But the rule of thumb, and I'm probably going to make a lot of the Autodesk development guys, at least the Inventor guys, upset. Don't use import. The Twig importer, just don't, okay? Resist it, don't. It's going to cause you all kinds of headaches. It's just hard to use. Don't do it. So I'll show you a little better way to do it. Use copy-paste from AutoCAD. Have any of you guys done this? It's really slick and it's really easy. It's just a matter of going and grabbing whatever the profile is that you want, doing a window around it, copy, go into Inventor, go to the sketch, paste. That's it. Put it where you want it, put your dimensions on it, constrain it the way you want, and you're good to go. The thing that's nice about it is you have a lot of control over what's imported. So you can ignore, remember all that ugly text and all that other stuff that I had on there? I can ignore all of that, right? I don't have to worry about it. Even though that the drawing importer has things like layer filters on it, right? You can have it turn off filters. I don't know about you guys, but I haven't run across a whole lot of drawings that everybody followed the layer structures and everything the way they should, right? Especially because they're passed around like a bad penny. A lot of the drawings are. They go from one place to another, and you know, it's kind of like a chain letter. Yeah, layer 0. That's usually a popular one too. They're all on 0. So what you get is a lot better performance. Things work a lot faster and a lot easier, and you get lighter, smaller models. Okay, and this is important. It's actually a key thing, right? You think about it with a plant, depending on the size of it. A small to medium business, small to medium-sized business or a manufacturing facility is probably anywhere between 50 and 100,000 square feet, right? You can get a lot of machines in 50 or 100,000 square feet. Imagine now if you take that to the scale of a place like General Motors, where you've got 3.5 million square feet under one roof, right? What became difficult now becomes absolutely unmanageable. So the whole idea is you want to keep these things as small as possible. I liken it to if I built a new house and I put up a 3-car garage, I'll be happy with it for about a month because I'll put enough stuff in it that I should have built a 4-car. And that's exactly how these things work. So remember, you always got to keep that in mind. Keep things as small and compact as you can. It's just kind of a rule of thumb. And I think I'm kind of beating a drum there. And it's something we've known with AutoCAD for a long time too, right? Just kind of keep them small. We've all gotten lazy now, right? Because hard drives are bigger and RAM is cheap, right? But that's going to run out of gas sooner or later. Especially when you start talking about doing this stuff across the web, right? Because now we've got another problem. We're talking about bandwidth. So we don't want to remove big chunks. Now this is another thing that's really important too. When you bring things over from AutoCAD, a lot of times, well, obviously, it's going to have fillets. These are all part of the design, right? When we worked in 2D, you had to show that stuff. Don't use them when you come over into the AutoCAD or into the Inventor environment. Don't use them. Delete them. Get rid of them. Close up the profiles. Okay, and then you can use that for doing your, for bringing in there and extruding your sketch. So you can see we've got that there. Now, if you feel that you absolutely have to have the fillets, because it just doesn't look cool without them, all right, put them in as features. And what I also recommend, this is just a standard good modeling technique, do it at the end. Okay, do it as the last thing you do, because if you find out that the thing's too bulky, you can always take the end apart marker and move it up and get rid of all the fillets. And then you can start taking a look at how it looks lighter. Okay? So it's just a good rule of thumb, good way to work. The same also applies for holes. If you've got circles that are there representing holes, don't extrude them as circles, okay? Get the center point, use Inventor's hole tool. Get a lot better performance, and the other thing you're going to get too is a lot better manipulation and control of the model, because now they're features instead of being sketches. Okay. So are there any questions so far? Yeah, absolutely. It's available on the website. It's all up there. I've got it in a PDF format, and I've got a Word document that supports this as well. So they're both up there. And you're welcome to reuse them. In fact, as far as I'm concerned, if you guys want, do you want the regular .ppt PowerPoint? If you want it, I'll put it up there for you. I don't care. I'm not that way. Okay. So, no problem. So, there's a really neat tool inside of Factory, and this is unique to Factory Design Suite. It's called the Twig Overlay, or the Drawing Overlay. Okay? What it allows us to do is to bring in an AutoCAD drawing, and it resides like an onion skin on the floor. So you think about it, it's like painted on the floor, right? What's cool about it is there are no vectors there. There's nothing there, but you can use that as a background to trace stuff. So it makes it very easy to kind of find where things are. Another thing that's important to remember here, too, with this stuff, accuracy is good, but it's not absolutely paramount for what we do, okay? If we're within 1/8 of an inch or 1/4 of an inch, we're doing pretty darn good. We're close, right? The reality is, especially when when it's 2D stuff, that somebody is taking, and I used to do this, right? Like I said, I did it for a living. We were taking stuff from the plant floor and putting it into a CAD format, which involved me walking out into the plant with a tape measure, measuring out the machine, sketching it all out, right? So it's only as accurate as I measured, if I was distracted that day, having a bad day, whatever, right? So I'm only going to be as close as I can be. So the reality is here, we don't know. If you're getting the drawings from somebody like a vendor that's actually building this, they're probably going to be fairly accurate. But again, don't be overly concerned about that. Okay, we don't have to be down to like 6 decimal places here. Last time I checked, I don't think anybody can pour concrete that flat. Right? I haven't seen too many guys who can weld that straight either. So the thing that's nice about this too is it's very fast. You can do things, you can generate things very quickly, and it doesn't carry all of that extra weight along with it. So it keeps everything very simple. So all your profiles and everything become very simple, and it allows you to be able to ignore what you don't want. Okay? So how to leverage Twig Overlay. He's going to go now and perform without a net. So let's see what we can do with this thing. We'll show you exactly how it works. Okay? Again, any questions? Hopefully I won't die here. I don't think so, though. I think I'll be okay. All right. So I'll take just a second here. You know, this is like the end result. Okay? If you look at, what's that? This is a mist collector. So it's something that you're seeing a lot more in high production machining shops now because of OSHA. And they've discovered over the years that people actually got things like cancer from breathing in all that coolant that was floating around in the air. That really was a bad thing, right? They discovered that was bad. So now you're starting to see more pieces of equipment like this. And so what this does is it goes on the end of a machining line. There's ductwork that's attached to it, and it attaches to each of the CNC machines, and it sucks away all the coolant mist. Okay? So we're going to take a look at this. In fact, I'm going to back out of here real quick. We'll just delete this. Okay? So if we look inside of here, what's a little different for you guys that have used Inventor before, okay, but have never used or seen Factory Design Suite and what it does, you'll notice that we have this concept of what's called a floor. Okay, so the idea is when we place things such as assets, and I'll just give you a second here. We'll talk a little bit about what assets are. What assets do then is we can go place these. So, for example, let's go get, go grab something from in here, I think. So if I grab this, for example, and drop it in, it automatically knows how to behave, right? So it goes on the floor, drops into place. So the whole idea here is you don't have to be some kind of a CAD guru genius to be able to use these types of tools. You can take and drop things in very quickly and build up layouts, okay? Now look at the detail, the amount of detail that's on this. Did any of you guys attend Steve Schucard's class this morning? It was Do's and Don'ts on Creating Assets? You should have. He's really good. Okay. But at any rate, we'll just take a second here and talk about it. So you see these, they look actually a lot more complicated than they are, right? They're very lightweight. You can drop them in and out very easily. So there's a couple of different techniques we can use to build these, like I'd said, and this is the one that I want to show you here, is one that I've used quite a bit. So inside of Factory, we have, in the layout tools, we have something called Add Drawing Overlay. So the one I'm going to grab here, the first thing I did is I did scale this one. I discovered as soon as I started working on it that it was a scale of 1 to 5. And I made the mistake that I preached it to you guys to check on. I built my first one and it was 5 times too small. Right? Would have been great if I was using it for G.I. Joe. Okay? So if we take a look at what we've got here, there's our drawing. So I'm going to go into AutoCAD, and we've also got our drawing over here. So we can work in a couple of different workflows here. Now the first thing we want to do, though, when we're creating this, is we want to take a look at it and see what's going to be the biggest body that we can use in here. Okay, what's the biggest chunk we can make, and then we can start bolting or hanging things on it all the way around. So to me, I'm going to take a look at the views that I've got here. The one that makes the most sense to me is the top view. So I'm going to steal some stuff from this top view. Basically, I'm just going to grab any of these things are here. And you notice there's fillets on the ends of those, but I'm ignoring them. Okay? So we can take and throw that in as well. Maybe grab something like this. Now, I could do this, right? But as I'm getting in here, I'm starting to see that this profile is kind of busted up, right? It's probably not going to work real good. So what I'm going to do instead is I'm going to jump back over to Inventor and simply trace. So we'll go on here. Now I'm not going to snap to anything here, but because I have the DWG file, I know what the dimensions are. So I can go in, for example, and start working on this. And in this case, I want to go to the XY plane and create a new sketch. So now that I'm on that sketch, I can simply start laying in the rectangles here. Now, to me, it's not all that important, at least for my representation, that we have that little tiny step in there. I really don't care, all right? So what I'm going to do is get it about that size. And then I can always grab onto the profile and just kind of tweak it a little bit to make it look good the way I want it. And then extruding it, again, is a matter of just grabbing the information from my AutoCAD file and knowing what my height needs to be. So in this case, it's going to be 58, what are you saying, 52? That's what I'm going to call it. I don't think we're going to get too worried about the 04, right? Isn't going to matter anyway. So let's go ahead and extrude it. What? Oh. Okay, that's fine. So let's go ahead and extrude that thing up. In this case, we're just going to go 54 inches. But I went the wrong way. Let's go get that again. We'll flip that. There we go. Bring it up something like that. Wait a minute. Why am I getting cuts? Hang on a second. Oh, I know why. Before we do that, got ahead of myself. Create new component. Sorry, guys. I'm going to create this component, and the component is going to be called the HD mist collector. Okay, my bad. Let me explain what it is that I did there. Wait a second here. What the heck? Changed my project file. I messed something up here. Hang on a second, guys. Grab this guy. Let me go grab this. That one, copy it. My bad. One moment, please. And now, of course, Inventor doesn't want to let go of that last file, so I'm going to have to relaunch Inventor. Give me 1 second. There. That's what I get for showing somebody something about 10 minutes before I come in here. Right? So it's going to go to my projects here. We're going to go grab this guy. Start a new layout again. Okay. Layout tools. Grab that. There, okay. Back to my regularly scheduled program there. So let's go ahead and create the component. I'm going to go ahead and put that right on the XY plane here. Did I get XY plane? I don't know if I did. I don't trust myself. I'm going to do it one more time. Okay, so again, I'm just going to place it on this plane so we can go ahead and work on it. So again, let's look at the top. Let's grab that view. Create a 2D sketch here on the XY plane. So So now that I have this, let's go ahead and throw our rectangle on. From here, right to there. Extrude. This time 56 inches. Was it 52? Okay, you guys got good memory. I like that. Okay. So, got that put in there. Right, so we've got that put into place. Now we got this little box that goes on top of here as well. So we got to look at how that's located. It was nice of them, too, that they provided us with a 3D drawing of this thing. Okay, so we can kind of get a feel for it. That's a luxury. We don't usually get that. But at any rate, what I can do here then is I can draw on top of here. Let's go right to this guy. New sketch right on top. Maybe we'll draw in the rectangle that it's going to go over the top of it there. So again, just employing really simple techniques to get this stuff in there. Extrude that. And again, this comes up, I know, 10 inches. Okay. So now, to get some of the other features off of here, though, we're going to drop another new sketch in here. And this time, what we want to do is use that AutoCAD drawing to give us some of our information. So what I want to do is steal this circle, the circular pattern, or the nozzle that's coming out of the top of here. And I also want to grab maybe a frame of reference for that. So in this case, what I'm going to do is grab like this line right here. Okay, because what I'm looking for is something that I can place it and kind of line it up. Okay, so now I've got that, just using Control-C and jumping back over to Inventor here, and just Control-V. Now I can drop that into place. Let's see. What I'm going to do here is I'm going to kind of drop it off to the side here so I can show you what I mean. Okay, so we got that in place. Now it's just a matter of moving that. So I can grab all of that information, just like it is there, grab it by the base point right here, and then drop it in right on the end of here. Now in this case, I have to project the line. My bad. So we'll go grab that, and again, move. Now, remember before we were talking about, is this going to be a changeable or a not changeable? Okay? So this is kind of an important thing to think about here for a minute. If this was going to be a non-changeable asset, if it was going to be something that wasn't going to change in size, I don't give a hill of beans about where that thing's located in the middle of there. I just go ahead and extrude it, go on my merry way, right? But in this case, what I'm looking at is this is something that I may want to reuse again. I may want to make it a different size. I may want to be able to resize it and rescale it. So what I wish to do then is to start constraining it a little bit. And constraining means we're just going to add a little bit of smarts to it. So I'm going to throw a dimension on here, for example, just to give me the inside dimension, something to give me the outside dimension. And rather than using dimensions to put this into place, well, I guess I will, though, we can go ahead and drop this in here from there to there. That gives me my distance for that. And then the more important one is I'm concerned about where it's going to be on the center here. Okay? So before I even do that, what I'm going to do is add a dimension to the outside here. So let's go back. Let's grab our other sketch that we used for our original here. And again, like I said, I want to be a little smarter about this. I'm going to throw in a dimension that's going to represent the overall width. I'll take that and make it 32. And then we'll add something to the length here. And this is going to be 42. So now that we've got that in place, see what happened there? Everything kind of went goofy. That's because we didn't have that tied down. So what's going to end up happening is you need to throw a dimension in there to control it. So very quickly, let's throw in a dimension from here to here, across like this. And what I want to do is I want to steal this dimension from somewhere else. So, or even better, what I'd like to do is be able to control that later through a spreadsheet or something like that. So let's go ahead and hit our Manage here. Go to our parameters, and I'm going to add a parameter here. Width. That's going to equal 32. We're going to add one length. That's going to be 42. 32. Okay. So now, this dimension, I can change that and say I want this to be width divided by 2. Notice it's red. It's because I can't, there we go, because I used a capital. There we go, divided by 2. And that'll locate that for me, okay? So I'm going to go back to the other dimension too and do that. And then one other thing that I want to do with this is we're going to make this concentric about the middle. Okay? And it's a matter of extruding it. So in this case, maybe it comes up like 10 inches. We can grab that sketch that we have there too and reuse it. So, for example, see there's the extrusion right there. I can share that sketch and say that I want to extrude that one up maybe 1/4 of an inch or 1/2 inch. That's probably more detail than I should put on here, but I'll leave it just because it's a bolt flange. Maybe it's something important. Okay, so I could do this all day long. In reality, that shape, that if I wanted to, I don't want to bore you guys right to sleep, but I could basically create this entire object in about 20 minutes. Okay? I mean, from you guys, what do you think? Do you think that's acceptable for speed to be able to do that? Is that pretty quick? Okay. I don't know of a quicker way. But what's neat about these, too, is if we go and grab, again, this extrusion that we've got here, I want to edit the sketch on that also just one more time, and I want to add a little bit of intelligence to this. Okay? So in this case, we're going to take this and tell it I want that to be width. I also want to have this one be length. Not width, length. So I can drop those in there like that. We'll go finish it up. So what it allows us to be able to do, and I'm going to add maybe just one more feature here because I just want to drive this home, how this works, okay? So the last thing I want to do is I want to put the drop angles that go on either side. And some of the other pieces too, the electrical panel, right? Things like electrical panels are really important on these machines. Why is that? Because we have to have 36 inches between these. And a friend of mine used to call that the bacon distance. And what do you mean by that? Because if you're any closer to that and you touch the inside of that box, you're going to fry, just like a piece of bacon. So that's what he called as the bacon distance. So you got to be able to make sure you got that clearance. So it's important that we're able to show those types of things on our models. So again, I think I'll throw that guy in there too because I think it's pretty important. So we'll add the new sketch on there. Again, I'm just going to go back over to my AutoCAD. We'll go grab this box as it is right here. This is the one that's important to me. So again, I can just grab the geometry. So go grab that, this, and just kind of work my way around it. And again, very important to get yourself a reference line. So I'll grab this one. Copy it. Jump back over here. Paste it. Okay, so I'll take this and move it. The base point is right there to right there. And again, just extrude that. That's telling me there isn't a closed, I've got, there, see? That's what I was talking about stealing stuff from other drawings. You run into stuff like this. The nice thing about it, this one I can actually see it. So by using Inventor, I can very easily take and control these or close them up. So we'll take a look here. Yep, I got another one right there. Just go drop that in. Oop. We'll get that again. Right there. Okay, so now, going to extrude that. We'll bring that out 12 inches. Okay. And we'll add one other thing here to control or to show that door swing. So I'm going to drop a new sketch on top of here. And basically, I'm going to draw in a line. In fact, it might be even easier if I do it this way. Let's do a circle. that represents my door swing. And then I'm going to draw in a very simple line on here. So I can come out the 90 degrees, go get that. Then it's just a matter of, just like AutoCAD, going in and trimming out the circle. Bring it out as such. And do something just a little bit different here. So what I'm going to do is extrude this. What I'm interested in, though, is just the surface that's there. So I'm going to grab that information. And what we're going to do is tell that just to go to the bottom of here. Okay? So now when this shows up in my 3D layout, I can see that I've got that door swing that's on there. And I can cover that. I can change the color of it. I can do whatever I want with it. Okay? So what it does is it doesn't really interfere with our model per se, but it allows us to be able to put that kind of information in there to be able to reuse it. Now, like I said, I'm not going to go too much further here with the modeling portion of this. We'll kind of leave it where we're at here. But what I do want to do with this is I want to make a couple of different variations of it. So let's quickly go into into manage here, the parameters. And now what I want to do is make a couple different sizes here. So this one, we're going to do what's called make that a multi-value. So I'm going to make this a 32-inch, a 40-inch, and maybe let's go with 28-inch as well. 28 and 40. Add those in. So I've got those different sizes there. So I can see the behavior here because I was smarter about how I did this. If I change it 40, you can see that it stays centered, right? 28-inch gets smaller. We'll take it as a 32. Okay, so once I've got those created like that, it allows me to be able to access those parameters and be able to use them. So in this case, let's go ahead and open this, and we're going to create an asset from it as it is right now. Okay, I'm not going to put the legs on and the other pieces. But for in reality, what we've got here, in a lot of cases, is probably plenty. Let's go ahead and change its color too, because I don't know about you, but I'm not really fond of that gray. Not my favorite. Let's go ahead and put it into a color that we can use, like olive. There. Some of you see in plants most of the time, which really isn't a whole lot more exciting than gray, is it? But at any rate, that's just the colors that you see. So we've got that there. Now that sketch that we've got, right, that shared sketch, I really don't want to see that guy, so I'm just going to turn off the visibility on it. Now, just as a side note here, again, this doesn't really have to do with the 2D part of it, but you can change the way things look on here too. So if for example, I can go grab that outside of there and say that I want that to be like nickel. So that way when we lay these things into the layouts, they look like what they're supposed to. So when you're walking through here, everything looks nice and clean. And once we've got this, I'm going to go ahead and save it. And we're going to go to the asset builder and build one of these out. So now you see we have these available to us. We have length and width available. So I can go add these two parameters as they are. Okay? The other thing that's important to do here too is I have the ability to add things like connectors. So I'm going to add a connector to the top of here because I may want to, well, what I'm going to want to do is connect ducting to the top of this. So it's an intelligent connector, or it's a half of what like a half of a constraint. Okay? So when it's there and I drag in another asset and bring it over it, it's going to snap right into place on top of it. So we'll go ahead and put that in there. And lastly, let's go to the asset properties. These are very important. I don't know if you're like me as an engineer. I'm not a real big fan of typing either. But it's really important that you fill this information in, because these are the kinds of things that are going to allow you to be able to search for these things later on. Okay? Not only search for them on your machine, but if they're published to the cloud, These are the things that are going to be able to make you be able to find things on the cloud. Okay, so I'm going to put this as we're going to put this as MH2000, or well, let's just MH Mist Collector. Okay. Mike's Awesome Machines. Okay. The category on this one is going to be machinery support. Well, actually, let's put air cleaner. Air cleaner. There we go. Okay. So we can add other comments to this as well. So this could be environmental, filter, and so on, right? So you're able to go and search and find these. We can also add custom properties to here too. So anything that's available in Inventor, and also I can even add things of my own. So for example, I could put cost in on here. Yes? Yeah, the question is, would we be able to build different configurations of this? Different kinds of horsepower, different kinds of internals, and so on, for like ordering of parts and equipment? Yes, absolutely. So you can put that information in there. It can be put in as text information. If you want to do it with geometry with some of it, you can. There's nothing wrong with that. Are you guys familiar with iLogic? Okay. iLogic is a language that's inside of Inventor and basically allows us to be able to build really smart configurations. So you can tell it to turn things on, turn things off, based on whatever they are. Okay? Very powerful tool, pretty easy to use. So, yeah, the answer is yes, absolutely. So that way you can fill out your bill of material information will be correct. Okay? So we've got all of that information in place. I want to add a landing surface to it as well. The landing surface is kind of important too, right? This is going to basically tell it which way it needs to orient or snap. Okay? Insertion point. The insertion point is going to drive what the insertion point inside of AutoCAD is going to be. Okay? The first one that you place will be that. You can put multiple insertion points in here, by the way. If you do multiple insertion points, when you put these things in as 3D objects, you can toggle through them. So you can, choose whichever one works for you. But it's important to note that the first one is your snap point. And if you guys if you've built blocks or libraries of blocks, you know that, right? You want that orientation point or your start point. So that's basically what you're getting. Put it right there. Okay. So now we're ready to publish it. Now, I could publish this locally if I wanted to, but you know what? The theme of most of this stuff has been cloud, so I'm going to go ahead and post it to the cloud. Okay? So I have my own collection of all of these objects that are up here right now. In this case, I'm going to add another category up here, and this is going to be for air cleaners. Okay, so we're going to put it in there. We have the ability to choose to publish or not publish the 2D asset. And I just thought of something. Before I get too far along here, I better make some variants out of that. So I want, actually, this is going to be the small. And I'm going to grab the width and drag that in here. We'll put another one in here. This is going to be medium. Remember those drop-downs? So I can go grab those. It's a 28-inch. And then again, large. Okay, so now that I've got those, let's publish that asset. Again, going back to the cloud. Right at the top there. Oh yeah, it starts with an A. That makes sense. Okay. So, and also what I'm going to do is I'm going to tell it to share this on publish. Okay? Now, I can go up and tell it to share it later on if I want to. But let's go ahead and do that. So right now, Inventor is going to go ahead. It's created the 3D model. It's going to create every 2D view it needs for each of those variants. And what those end up being, just to give you focus and context, it's just a drawing file, okay, a DWG file, and each of the variants inside of there is a block. So what it does is it swaps out the blocks as it needs to, okay? It's pretty smart. You can do a lot with it. So it takes a few minutes for it to get this done. Any questions? Yes, absolutely. I mean, do you guys think this is something you could do? I would think so. I always like, the thing I always kind of liked when people would ask me, and I used to be an AE also, and people would ask, is Inventor hard to learn? And my reply was, well, you learned AutoCAD, didn't you? Right? AutoCAD's not an easy tool to master. It's a powerful tool, but it's not easy. Inventor's much easier. Yes? Mm-hmm. AutoCAD 2013, yeah, that's a good question. Yeah, so the question is, basically, will Inventor read in the parameters that you did in a 2D parametric sketch? Is that correct? That's a good question. Could you have extruded inside AutoCAD? Absolutely, but the only problem that you'd have, you wouldn't have parametric control of it. It'd just be a solid, right? Not to a base solid, no. Yep. Absolutely. I can change the diameter of the stack if I want to. I can do whatever I want. You can in 2D. Okay. So we've got that done. Finish the asset builder. So we'll go back to our assembly here. Actually, let's start a new one. Absolutely. Revolve features and also what are called an intersect feature. So you can do both. You can do it either way.
We do a lot of pumps and tanks, and to make those 3Ds, it's a lot of times it's better to draw half of it, take a P-line, and revolve it in regular auto.
Yep. Since we have some time, I'll go ahead and create one like that. So if we go here, it's exactly right. So what you end up doing is this. It's just a matter of creating a rectangular section. And in this case, maybe we'll make this, I don't know, we'll make it 40 or 36 inches across this way. And we're going to make it 72 inches this way. Wow. Okay. Not as big as I thought. By the way, this is one other thing that's kind of neat about Inventor. If I go in here, say for example, let's go grab this dimension. It's 72 inches, which actually is 6 feet, right? Minus 12 millimeters. Okay? Try and do that in AutoCAD. Right? Yeah, dogs and cats living together, total anarchy, right? You just can't do it, right? So let's just go 6 feet on that again. And now, exactly like you had said, so I can take this and revolve it. I just choose that, and then choose my axis that I want to revolve about. And then I can do some kind of cool things too. For example, I do want to round on the bottom of this. And I'm just going to give it to a size of maybe something like about that big. And then I want the top of it, since it is a tank, let's shell it. That we want that to be 0.25 inches thick. And there you go. There's your tank. Certainly did. All done. So then you can change the size of that. You can work with it any way you want. So yeah, works really quick. And that's for round parts. That's definitely a good way to work. So again, you can use the same workflow, right? You can go grab the 2D geometry from your AutoCAD, bring it in here, constrain it the way you want it, revolve it, and rather than, but what you don't want to do is don't bring in like a section view of it where you got like this little thin wall thing there and go grab that and revolve it. Don't do that. Do what I did here. Grab the outside, revolve it, and shell it. Because that way you've got total control of this thing. You can do whatever you want with it. Oh, by the way, one other thing that comes along with this, just so you guys, for you guys that don't know, if we go to the properties of this thing, it's physical properties. So let's take this thing and make it out of something a little bit more realistic. So we'll make this out of plastic. We can see what the volume is now, and we can find out exactly what that thing weighs. Okay? Now, that's nice because this happens to be accurate, but remember that axiom I said before. We're going to be bringing things in and taking all the guts out of them, so they're basically solid inside. But the nice thing about that is if we do know what the thing weighs, we can type it in, right? We can tell it what it is, right? So, again, just really easy to go ahead and create those. So, I've got my part as it was there. Let's go ahead and create a new factory layout. And now we're going to go and grab that thing. So if I remember correctly, I called it mist, I think, mist collector. So I'm just going to type in mist. It's going to go search all the assets, not only the ones on my machine, but also going to go find any of the ones that happen to be on the cloud. Check this out. So if I go here and I go Jolicom, right, which happens to be my login name, go find me all the assets except, did I spell it right? I spelled it wrong. That's pretty sad. Okay, so yeah, I'm used to doing it myself. So, but you can see then any of the assets that I've created and posted to the web, anything that happens to be out there, you can go find it. Okay, so really powerful search tool. Pretty nice. So again, let's use mist. Search for that guy. And then it's just a matter of dropping them into place. Something like that. And because, like I said, that thing's a variant, I can go to this guy here and say, grab that asset variant, say I want it to be the large one. And it changes right in place. Okay? And the beauty of this is, let's throw a few things on here. It'll come up with all my stuff. Everything that I posted up on the web and shared with everybody. Yep, it will. Another good one to do is Rusty. It's Rusty Belcher from Imagine It. He's got a ton of stuff up there, right? You guys got a bunch of stuff up there too. So, but we'll just throw in a couple of other pieces in here. Throw in a press. Let's throw in a couple of other machine tools here very quickly. Let's throw in this clamp. Yes? Yep. Well, you can. The question is, you notice I just have a very simple thing right there. It's just changing the width and the length. Can I do more than that? The answer is yes, absolutely. By using iLogic, I could basically say I've got configuration A, configuration B, configuration C. So I'd go and pick those, and it'll change everything about them that needs to be. And depending on if I leave some of the dimensions open on those too, I can also change sizes. With iLogic, I can also do things like putting limits on some of the dimensions, so I can't make it too big or too small. So there's lots of things you can do. If you guys haven't taken one yet, and if you're doing Inventor and you haven't used iLogic yet, look around real quick and find an iLogic class and go. I'm telling you, really cool. It's amazing the stuff that you can build with it. Okay, and it's really powerful. Have any of you guys done any VB? Okay, if you can do VB, iLogic's a piece of cake. Okay, works. It's basically that's what it is. It's iLogic. iLogic is VB for Inventor. Yep, exactly. Okay, so, oops. You didn't see that. That never happens. Okay, so, let's go through here. We're going to kind of run things down here. Important things to remember. Avoid using DWG import, that workflow. In fact, let me put that stronger. Don't use it. Okay? It's one of those kind of things that looked really cool. It looks cool. It demo's great, right? And like I said, I used to be an AE. I'd show that stuff all day long. It demos really cool. But just because you can doesn't mean you should. Okay? It's just not a good thing. Okay, check the drawing scales. Keep your basic profiles very simple. Okay? You notice how easy it was for me to make those altered sizes like that. It's because it was a really simple profile. I didn't have to put a whole bunch of constraints on it to make it behave. Okay? Use features where appropriate. Again, use things like fillets and chamfers. They're a lot easier to control, and holes too. Okay? Leverage decals instead of features where appropriate. You guys, I don't know if you're familiar with that, but Inventor allows you to be able to take a bitmap or a JPEG and paste it on the side of something. It'll also wrap around pipes and things like that. Works pretty slick. Okay? And that's the beauty of that is they're very lightweight. Okay, so it doesn't add any weight to your drawings at all or to your models at all. And also, I did a bonus on here that wasn't listed on the web. I actually showed you guys how to create a variant. Okay? So, questions again? Yes? That is correct. Thank you for asking. Yeah, the question was, those variants that I created, right? What do they do inside of AutoCAD? Well, they behave just like they do in Inventor. If you right-click on one of those blocks inside of AutoCAD that's a variant, you can go choose the other size, and it'll automatically resize. Okay? And when you make the change in AutoCAD, it will update in Inventor. If I make the change in Inventor, it will update in AutoCAD. It goes both ways. Okay? It's a one-to-one. Yes?
Sounds very similar to like a dynamic block in CAD. Is there any way that you can make it interact with the same grip, like for the stretchability to the length of the population?
Write that down. Write that down. That's one we want to be able to do, I think. We can't do it currently. It's part of our development team. So these are the guys that make this stuff happen. You should all applaud these guys. Seriously. It's good stuff, and they work hard to put this stuff together. But yeah, that's actually good feedback, and that would be neat to be able to have that dragging capability. You know, like for a fence, for example, drag it and it keeps just snaps to the standard sizes. I guess I'll write that up. I don't know. By the way, yeah, I don't know if you guys know this too. I'm product manager for this stuff. So I welcome feedback. I want feedback. Good or bad, I want feedback. Okay? Any other questions? Yes?
How do you take that model you just created and put it back in DWG?
Do you want a 3D one?
Yeah.
Yeah, you can use actually what's called a Twig export from inside of Inventor. So it's a matter of just saving it as a 3D Twig. And you're good to go. You can take an entire layout, in fact, like that and do it. So, and we've got people that are doing that. It's a little different workflow, but people do that. Yes? Really? Yeah, well, let's talk after this. I'm interested in that one, and like a precision thing. That's a little weird. I haven't seen that before, but yeah, let's. No, that's okay though. You know, I always look at it this way. Oh, maybe it's something I'm doing. That's fine, but the reality is you found it, right? If you found it, that means other people may have found the same thing. So I'm very interested in seeing what it is in your workflow and how you got there. Because what I want to do is make it so that other people just can't get there like that. Okay? That's the idea. The whole goal here is we want to make this thing so simple and easy to use that it's just a no-brainer to do this kind of work. If you're doing factory work, this is how you want to do it. Okay? So my goal is to make this thing as interactive, as easy, and worry-free as anything out there. Okay? Any other questions? Okay. Call to actions. Please do the survey. Okay. Hopefully I didn't suck. Okay. Now, this is also very important. For those of you that are interested, okay, we want to do feedback. We have product ideas. And this, by the way, is listed in the documentation that I have online. Okay. But Autodesk.com called FDS_Idea Station. So for anybody that's using Factory Design Suite right now, you can go up there and add ideas. And we take them and we feed them off to development. If there are things that we can act on quickly, we'll get them right away, or we'll look at getting them into future releases, if they make sense. The discussion groups, I guess, are there. And then one other thing. We're going to be doing a beta cycle for Factory. If you would like to participate, and we welcome you to participate, you got to let us know, okay? And as soon as you get that, we'll let you guys know when we go to beta. All right? So I'd like to thank everybody for spending some time with me this afternoon. I hope you found it beneficial. I enjoyed doing it. It's a lot of fun. It's kind of good to get away from the design thing and actually build. So enjoy the rest.